Well, good morning, good afternoon, everyone. So we will wait a couple of more minutes to allow participants to join. So we will start shortly. And I put everyone on mute to avoid any distraction, but we want to run the session very interactive. So please use the chat room to post any questions you have, and I will bring up to the attention of Shikhar. So we will start shortly. Okay, I will kick it off shortly. So good morning, good afternoon, everyone. My name is Murat Güvenç. I am Managing Director for Across. We are IBM Data and AI partner. And I'm very excited to basically run today's session with our AI leader, Shikhar. Before we kicked off, a couple of logistics reminder. Uh, I basically turn off my video, not because we are not ready, not fairly dressed, but just to leverage the bandwidth as much as we can. Also put everyone on mute so that we can avoid any unnecessary background noise. But please use the chat room to post questions, to engage with us, and we will try to run the session in an interactive way. And also I'm recording, so we will be sending you the deck and as well the demo script, the video after the seminar. Be time bound to 30 minutes to respect your time. So we will spend a couple of minutes with the intro, around 17 to 20 minutes with the content delivery, and the last 10 minutes demoing IBM Cloud Pak for Data. So all those materials will be distributed to you. So with further ado, I would like to introduce Shikhar Quatra. Shikhar, thanks for joining today's session. Basically, Shikhar is part of IBM Expert Lab Group, and he has in-depth experience in creating, designing, and evaluating the performance of machine learning models. We are very excited to have you, Shikhar, and I know you are honored as one of the youngest master inventor in IBM and over 230 patents under your sleeves. So it's a great honor to basically have you in our session. And basically, I will let you to introduce further yourself.
Thank you so much, Murat. Hey, everyone. Good morning, good afternoon, good evening. I'm Shikhar Quatra, as Murat mentioned. I work as a data and AI architect. I hold an IBM Master Inventor title, and my main focus area has been conceptualization and creation of ML ops, ML operationalization with governance and model risk management. I do want to keep this session very engaging, very interactive. Feel free to pause me, ask me any questions, poke around with Murat, and he will open it up for questions every now and then.
So Shikhar, if you don't mind, I want to basically ask the first question.
Sure.
So you have, again, many years of experience in data science field, and you're really one of the hands-on practitioners. You use different platforms and different technologies. So during my conversation with clients and with my colleagues, the same question comes all the time. What does operationalizing AI mean and why it's important?
Okay. All right. So I think I can best answer that question as we move along on the first slide, actually. So what do we mean by operationalization, right? ML operationalization. Right. So, okay, if someone understands, I think people on this call understand the DevOps pipeline, SDLC, software development lifecycle, right? In a similar way, ML operationalization is how do we operationalize your ML models? think of it from the analogy of, let's say, I would say engine of a car, right? Creating an ML model, that's just the starting point. That's just equivalent to building an engine of an entire car. But if you want to operationalize the entire vehicle, you need the infrastructure. You need the infotainment system, the gears, the tires, the front and the back. All the entire infrastructure is required in order to bring that particular ML model into production. So just like you have DevOps, you need to move your ML models across this entire end-to-end pipeline. And that's what we refer to as operationalization of your machine learning models. So basically, once you are done with building your ML model, you need to build a complete data pipeline for continuous training, automated validation, doing even the version control of the model. Maybe the model is not performing according to your expected accuracy, the performance metrics that you would have said. That's when the retraining of the model occurs in an automated fashion rather than ad hoc. And then you create this entire scalable servicing infrastructure with monitoring and alerting, thereby ensuring that your model is transparent, your model is scalable, and you do have business KPI mapping, which can be showcased to the C-suite execs of your company. Okay, so the main challenges that we usually face with clients, right? There are a lot of clients. I've been working with different banks at this point, from companies across healthcare sector, telecommunication, you name it, right? So when we look at MLOps, the main pain points that people have is how can we reduce the time between model conceptualization to be leveraged into production? How can we bring it into production as soon as possible? And usually clients would have hundreds and thousands of data scientists currently who are working on different machine learning models. How do we provide business value for those models? How can we enable tens of millions of requests in a day? Like, how can we send multiple scoring requests, be it batch, be it online scoring, be it multiple streams of data that's coming into picture? How can we institutionalize this collaborative approach between these different teams who are usually working in silos, but we want to have that kind of DevOps based pipeline with more lineage capabilities? How do we track the model? How do we track the data? And eventually, how can we explain the auditors? Basically, how can we provide explainable insights behind why the model is predicting in a certain way? Is there any reasoning behind it? What are the most important features that lead to it? And all the software engineers or data scientists on the call would be able to relate to maybe some machine learning algorithms, some AI-based approaches like explainability algorithms, which have been upgraded on the platform in order to get end-to-end explanations for every use case which is predicted by a predictive model, by a classification model. And in the end, they need to have an optimized infrastructure to support all of these services on a scalable platform. Now let's look at MLOps from a high level perspective, right? As a data scientist or a business analyst, perhaps, I would be mainly concerned on using different machine learning algorithms like XGBoost, like predictive model, classification model, time series modeling, all that stuff. But even before I embark on the steps of building a particular model or deciding the algorithm, I need to first prepare that model for the purpose of model development. So when we talk about preparing the model, it usually involves like data preparation, right? Like data transformation, which is basically transforming that raw data, which can be consumed in the model development lifecycle. But even before doing the data preparation, the DB admin or the administrator of the company who is handling all the data, maybe it can be data steward as one of the personas, it can be your administrator who would be providing that data with some governance rules and policies. Let's say you have sensitive information, you have PII data, you have GDPR rules and policies, which are which need to be associated with certain data assets. And then you want to provide a particular selection of those data assets to the data scientist or a data engineer for the purpose of model building, model development, all that stuff. Now, once you are done with these first three stages, right? The user has been provided the data, they have prepared the data for model development. The next thing is independent model validation. you might be sitting anywhere in the world, be it US, Canada, Africa, India, and you have your own test data where you need to validate the performance of that particular model. So there needs to be independent model validation as we move along the pipeline, where multiple data scientists are coming together and trying to assess the quality, the performance of the particular machine learning model, which might have been promoted into a particular deployment space. Right. After we are done with deploying the model, let's say you're happy with one or two particular models, which you would want to move from your development to staging to production environment. So in that case, we have something called WML, Watson Machine Learning, which helps you in exposing a REST endpoint where you can actually use live data, you can deploy those particular models and continuously consume that particular model into your production environment. And eventually you have that continuous performance monitoring of the model, which includes not just the accuracy of the model, but we are also talking here about the drift in the model accuracy over a period of time, drift in data consistency. What I mean by drift in data consistency is you might have a set of training data, which was very different from the live data that you were using at the time when you moved the model into production. So number one, how can we provide explainable insights? And at the same time, what is the drop in the data consistency and in the accuracy of the model simultaneously over that period of time? And this end-to-end life cycle is what encompasses ML operationalization. If you want to check out more details for people who are not familiar with the MLOps framework, you can always check out this particular link. It's a Medium article that we have posted. And along this life cycle is what we call 5Cs, which means continuous training, continuous integration, validation, deployment, and continuous monitoring. So you need to have an infrastructure where we can have this kind of end-to-end pipeline enabled and can actually create this kind of scalable infrastructure on the environment. Okay, a couple of non-functional capabilities to look for. And now I'm not talking about from an IBM advocate. I'm talking purely from the aspect of imparting some knowledge, if you will, on all these different platforms. As an ML practitioner, you would want to play with different platforms and check all the capabilities, all the services that are being offered on those respective platforms or frameworks. So we need to make sure that all of them do, or at least a few of them do provide governance capabilities. How well does the solution support governance and discoverability of assets? Can you create a model lineage? Can you create a data lineage, thereby tracking how the assets are being moved from the first stage that we talked about in the previous slide till the end, right? So you need to have governance. You need to continuously perform model monitoring. Explainability is an important feature. How does the platform support open source technologies? That has become a key differentiator for different platform providers. How well does the platform support enterprise grade security access to the platform, whether in terms of authorization or authentication? And then there needs to be a support for 5Cs, as we talked about: continuous training, validation, deployment, integration, and monitoring. So you need to have all of these flexible capabilities in order to enable an end-to-end MLOps lifecycle. If we purely talk about what IBM is offering on the table, you have something what we call IBM Cloud Pak for Data, which enables a hybrid strategy. In this case, you might be running on IBM Cloud, AWS, Microsoft Azure, Google Cloud, even user provisioned infrastructure. You might be running on bare metal, or you might have your own virtual machines. Now, the beauty is that you can easily set up an end-to-end MLOps lifecycle with not just your native services, but an end-to-end integrated platform like Cloud Pak for Data, which is sitting on top of your particular private or public cloud, and then, or any other infrastructure for that matter, where you have Red Hat OpenShift, which is installed on top of that platform. And on top of that, you have Cloud Pak for Data, which comes with a lot of services which are tightly coupled together in an integrated fashion. So you don't need to spend a lot of time on picking and choosing all the different third-party services when you can just, by a click of a button, enable some of these services right on Cloud Pak for Data as, think of it like modularized, containerized instances that you can enable or disable at any point of time. So when we talk about Cloud Pak for Data, let's say you have different data sources. It can be HANA, Hadoop, Impala. You can look at DB2, Oracle database, MongoDB. All of these third-party data sources can be connected through global connections on the platform, and using something what we call data virtualization as one instance running on top of Cloud Pak for Data. As soon as you enable it, it has the capability to virtualize your data assets and bring it on top of the platform. And that way you can easily basically connect to different data sources and establish that connection, seamlessly pull them into a virtualized table on top of the platform. You can join different tables, use SQL queries in order to enable those connections, and even use like JDBC, ODBC drivers for any third-party connections that you don't see on the platform.
Shikhar, this is
Yeah.
Murad. I have a quick question, basically what you're describing. We know that moving data is costly and risky and most of the time slow. And in many cases, in many industries, there are policy or regulatory constraints with moving and copying the data, right? Personal information or health information. So you mentioned that data virtualization makes data accessible wherever it lives and without the risk and cost of moving it. So can you please elaborate it? I think it's very critical for many organizations to have this kind of flexibility to be fully compliant with regulations.
Sure, absolutely. Yeah. So when we look at data virtualization, when I say like we are virtualizing all of that data, yes, you are not physically moving any of those data assets. That's a good point. You don't want to move physically any of those data assets and bring onto the platform. You might have some security rules and policies intact with your third-party connections. You can always have LDAP, data access, data security associated with those data connections. And then instead of physically moving those data assets, when I say you are virtualizing those connections, you are actually fetching the metadata associated with those third-party connections by creating those JDBC, ODBC connection URLs, bringing onto the platform, and hence not physically moving those data assets. So that's a huge plus point when we look at different clients who would want to leverage data virtualization and not risk any of those, I would say any of those rules and policies that they would have set up with respect to the platform. And the next thing is like when it comes to data virtualization can be easily integrated with WKC, Watson Knowledge Catalog, which in itself is a very scalable infrastructure, which is used for cataloging and governance of those data assets. I would showcase that to you quickly in the demo as well, but in interest of time, let me quickly move ahead with just a brief overview, I would say, of how you are cataloging those data assets, right? So you have different catalogs that you create, you pull in or publish different third-party connections on the catalog. And in the Watson Knowledge Catalog, you can have different rules and policies, let's say PII information, sensitive information. You might want to secure social security number and hide that, encapsulate that information. So certain feature sets can be profiled, can be encapsulated, and then you can have different assets being shared with different parties of interest in your organization, thereby having complete control over your data assets. Moving along to the next stages, after WKC, the next thing that we talked about was the user is being provisioned with some of the data assets. The next thing is transforming that raw data, what we call like feature engineering, where you can use something like data refinery as one of the modules, which is more of a UI-based approach for transforming raw data, doing some business level feature engineering as well. Or you can use Jupyter Notebooks. I believe most of the people on the call are aware with interactive notebooks, how you want to leverage those and code as data scientist, using Watson Studio, or modeling approach as well. The next thing is model development, right? Where one thing is you can use Auto AI, which is more of like an automated approach. There are other platforms as well which support creation of model pipelines, But the competitive edge, what we have is saving those particular model pipelines as a notebook as well. So you can have a very enlarged, a very transparent view of how Auto AI was able to generate a particular model. In a similar way, you can always use Jupyter Notebooks, RStudio, Jupyter Lab, which is also running as modularized instances on top of Cloud Pak. Or you can use something what we call decision optimization, which is more of a prescriptive approach. Let's say you were working on inventory management. So you did the sales prediction using your machine learning model. And now you want to see how many mobile devices would be sold in New York. So which is more of like prescriptive ML. So using decision optimization, we do have a competitive edge of how we can use that and then provide prescriptive analytics on top of your predictive models. Then after you have developed the particular model, you would like to deploy your model and expose a REST endpoint, a third-party endpoint, which can be invoked and used into your application. So using WML, again, another instance running on Cloud Pak, you can basically expose your REST endpoint to be used into your third-party application. And you can always do scoring, online scoring or batch scoring on top of your packaged model and then use it in your application. In the end, you have Watson OpenScale, which is what we covered in the last, in the previous slide on the last section, right? Performance monitoring. You need to do data drift. You need to understand explainable insights. You need to derive the model reliability, model accuracy, and fairness of the model. What I mean by fairness of the model is, can you really trust your model? Is there any bias in your model? With the change of age, gender, ethnicity, does the model output vary? And based on that, OpenScale is automatically able to recommend certain features which are prone to bias and then use some novel data perturbation technique in order to understand the level of fairness or bias in your model so that you can actually trust your machine learning models. And this end-to-end lifecycle is what we call it, using this CI/CD service, this end-to-end MLOps pipeline. And you can always follow the best practices of separating the dev to UAT and the prod environment, where all of these user personas can be even more, right? This is just one of the embodiments, one of the examples where you can have these personas working together and trying to create this end-to-end framework. All right. This is just another view of ML operationalization spread across these three environments, right? So you have continuous training, integration, deployment, monitoring, validation of that particular model, where I talked about fairness, drift, quality, lineage, and scoring of the model. Once you're happy with your model, you would like to move it into the production environment for continuously ingesting the performance metrics. Quickly, before diving into the demo, I know we are on short on time. I will like to spend 2 minutes on the MLOps in action. So as a data scientist, you would request for certain tables, right, to support your data science use case, let's say customer churn model or some kind of time series model or prediction use case. For that, the data steward who is actively looking into what's a knowledge catalog or basically looking into connections, different data sources, you can easily discover different data sources associated with different rules, different policies. And the data steward can try to identify certain data assets or data sets which can be provisioned from those third-party tools onto the platform and then shared with the data scientist. Now, the data steward has actually looked at different kind of data sets, and he wants to add those data sets to the catalog. And at the same time, the data steward can provide permissions to the data scientist to have access to 1 or 2 data sets or a plethora of other data sets with those security rules and policies. Let's say it has customer information as well, and you want to hide certain pieces of information which won't really help a data scientist, right? So data steward can add some governance capabilities on top. We talked about data virtualization, right? Which can be handled by our data engineer persona, who can add different data source connections to virtualize different data assets, join different data assets together, and then provision the same to the data scientist in the end. So this page basically covers the data provisioning and governance aspect using WKC and data virtualization. On this part is basically the second half of the pipeline. So you have governed data ops and you have governed ML ops, right? So this part is the second half of it, where the data scientist is now given the access or provision the access to the catalog. He can do some data transformation, and he or she can start with developing an initial model. Now the data engineer, the validators can work together in order to independently provide feedback, validate the model, generate a model fact sheet, and then check how your model is performing in your development or UAT environment. And once they are happy with your particular deployment, you would like to move that particular model into the deployment space, into the production environment, and continuously configure the model for monitoring with respect to bias, quality, drift, explainability, and monitor those results in a regular fashion. And I do want to show you what I have created here is an end-to-end MLOps starter kit, which can enable all engineer, data scientists, business analysts, all the C-suite executives to actually leverage this platform and then look at all the end-to-end capabilities with some of the use cases that I'm currently working on, let's say customer churn, some industry accelerators, etc. Now, quickly, in interest of time, let me just move into showing you some of the capabilities of the platform. All right, so here I'm logging into our Cloud Pak for Data platform. And if you understand the AI ladder, right, you have collect, organize, analyze, and then the fourth one is infuse, which comes into picture when you have installed that particular instances on the cluster, like Watson services, Watson speech to text, text to speech, visual recognition engine, all that stuff. If we look at I'm just going to log in here as a different user. All right. Okay, so if you look at the collect aspect, right? So you do have data where you can connect to different data sources, as we talked about. You can always connect to different databases or different data sets. And at the same time, you can virtualize your data sets, as we talked about. So you can create a virtualized view in order to bring them onto the system. Here, I do not have any virtualized data yet, but you can always submit a new data request. For instance, I need some information related to customer churn, and then add it with respect to a telco churn model, set the priority as high, and access the data using need customer churn information. And then you can submit that request. Now, if we go back to the home page, you will see that a data request has been posted, which can easily be accessed by a data steward, and they can publish some of those data assets to the catalog. So here are some of the completed requests or pending requests, if you will, which can take a look at some of these data sources, data assets, which can be provisioned on top of the platform. The organize aspect, when we look into organize, right, you have different catalogs which you can connect to. Like in this case, I've created one particular MLOps catalog, and I want to add different data assets or provision control to different users to this particular data asset. So I can always go over here and add different users to the particular data asset that exists in the catalog. Now let me move into, let's say, a particular project, right? So here I have created a bunch of projects using scikit-learn, Spark, Auto AI, and then I'm just going to open one of these projects here to show you how the project tab looks like. So here you have a bunch of these data assets. So I was working on a customer churn model. You can always connect to different catalogs. So here I have a default catalog where I can access some of these data assets, bring them onto the project if I have been given access to that particular data asset, and then it would be reflected over here in the assets page. You can always load from your system, or you can add to the project any third-party connection that we talked about. You can create any global connections or any kind of new connections like third-party services like Amazon, Apache HDFS, Dropbox, FTP servers, Cloudera, Impala. So you can connect any of these third-party sources onto the platform and then get started with your model development. If we look at different machine learning models, right? So I have one particular model which I have moved into production. So you can always look at that model and take a look at the schema or any other information. You can promote this particular model to a deployment space. So here I am trying to promote this model to a deployment space. What is happening is in the deployment space, it's packaging that particular model. And now as soon as I deploy this model, you would be able to have a view of that into your Watson OpenScale. So let's say I deploy this model with online deployment, model name La La Land. All the weird naming conventions are basically something that I like to keep for my models. Don't judge me based on that. Okay, so this model is currently being deployed. I will show you, I'll go back to my homepage and show you some of the models that I've already deployed here. So here I've created around 47 different model deployments on the platform. And when you move to Watson OpenScale, I just want to show you a brief overview of how it looks. So here, there are a bunch of these models that I have currently deployed. And you can take a look at the quality, fairness, drift. And you can also receive different alerts, different thresholds that you would have set for the fairness, for the quality metric. And take a look at how OpenScale actually creates a de-biased model, a model which is more trusted and which can be moved into the production environment. Here you can always compare different models together for the comparison. Like I want to compare it with La La Land model. And here we have this credit risk model. Here, and when we are looking at comparison of models, we are not just talking about the quality of the model or the accuracy of the model per se. We are looking at the fairness, the quality, the drift as well. What was the drop in data consistency? What was the drop in accuracy of the model? And then if I'm happy with a particular model, I can move it into the production environment. As you can see here, this model has been approved and moved into production. And when I move the model into the production environment, I would like to show you just one particular model like, yeah, this one, where it's kind of like a time series graph where you can see how your model was varying over time, how OpenScale was able to create a more fair model by understanding the bias metrics and the quality as well as the drift in data consistency. All right, I know we are on top of the hour, so you can take a look at the fairness metric, at the quality metric, and the drop in accuracy over a period of time. And then you can click on any of these transactions in order to take a look at how OpenScale perturbs the data set and then tries to create a different version. Here, the model is still generating those transactions, hence no new data has been added yet, but you can always take a look at some of the explanations, set up the machine learning providers, and then consume those insights into the model. As you can see here, for the customer churn model, these are the most important factors that influence the prediction, and these are the minimum changes that are required for the variation in the model outcome. And hence these factors and these model metrics with these variations are able to provide end-to-end explainable insights to why the model was predicting in a certain way. And I believe that covers our end-to-end life cycle. So I'll stop over here and hand it over back to Murad.
Thanks, Ricard. Thanks for the inspiring demo and the presentation. I think it is really impossible to demo everything in 10 minutes, but it is awesome. So for the participants, we would like to extend this invitation that if you'd like to take a closer look and a little bit spend more time understanding how each component works, we are happy to do that. So before we wrap up, Shikhar, just to respect, there is one question. You can see it in the chat room, but I will rephrase coming from Gokula Mishra. So basically what he's saying, based on the study done by BCG and MIT, only 20% of AI models get into production and create business value. And he's asking, what's your point of view on this?
I absolutely agree with that. The reason that 20% are usually moving into production is because, and even that measure, I would say, can vary over time. Because people right now are mainly making machine learning models without independently validating those models, assessing the quality. There is something called federated learning, where different data sets are brought together on the platform, and then you create model pipeline, and then you version different models together. So if you use any of the platforms, right, any of the MLOps platforms, you would see that there needs to be model retraining and continuous assessment of those models. And how can those models be actually used into your third-party applications? Right now, we are still in that era of understanding the complete end-to-end capability of MLOps. And that's why right now there is because of the applications that we are trying to look at, there are very few models that actually see the day of light in the end, eventually are able to move into production. But over time, I assure you, by 2021, 2022, as we are moving along this MLOps pipeline, the number would definitely increase, and we will be able to see that end-to-end capability augment over a period of time.
Perfect. Thanks, Shikhar, for the answer. And Gokula, I am happy to schedule one-to-one calls, sorry for your being on mute, so we can discuss in detail if you require more information. So with that, I wrap up the session. I appreciate everybody's time. And as a follow-up, you will be receiving the deck and the video, and hopefully we will have a quick chat to understand how we can help each other more. So with that, Shikhar, again, I appreciate your time and this great demo and presentation. And I wish everyone a great afternoon. Take care.
Thank you all.